So today we're going to talk about a very important distinction in object-oriented programming, and that's this concept or the distinction between objects and classes. Our course is about object-oriented design, but what we'll actually see is, we tend to spend a lot of times thinking about and writing code in terms of classes. Understanding what the differences between those is fairly important. So one of the ways I like to do this is using the following example. Okay, so I have this little Turtles starter zip file here. So once you download that, and I've already downloaded it. I have it here. I'm just going to go ahead and open that up, and then I'm going to grab that Turtles folder there and just drop it to someplace. So here's my directory for the course, and so I should be able to then open that up in IntelliJ. Let me go ahead and start up IntelliJ. Okay, so now I should be able to do an open, and let's see. I'll navigate over to where I have my file. And there's the Turtles project. Okay, so I'll click OK, and that'll kind of spin away, etc. Loads up, and you'll notice there's all the stuff. Okay, so a couple of things. One, you'll see actually there's this libs folder, and inside there is actually a class library put together by my colleagues Barb Erickson and Mark Gusdell over at Georgia Tech. And mainly the thing that we're using this for, there's a class in here that implements a logo style turtle. That is a turtle graphic style turtle, and that's really what we're going to use to kind of play around with this concept of looking at the difference between classes and objects. Okay, so all that stuff's there. As you can see here, it's in the edu.gatech.mediacomp package. And, if you're really interested in what all is inside that particular library, you can actually go to our link here in our class and see. No, I didn't actually want to download that. Apologies. Right. And so actually, I should probably put the better link. I don't think this is the correct link that I really wanted, but nevertheless, this will actually show us, for instance, there's the turtle class, a simple turtle, a bunch of different things. And so, we can find out, for instance, let's say with simple turtle, okay, that didn't work. All right, I'm going to have to look into what's going on with all that. However, I do have posted for us an alternative way of looking at this, and this is something that we're going to talk about a bit more in this class. I'm not going to talk a whole lot about the notation today, but I do want to at least start to introduce this. Okay, and that is the concept of the UML, the Unified Modeling Language. And in particular, what we're interested in are class diagrams. Okay, so here, what I have is this is just a little browser, little thing that web page that actually shows classes, or rather shows UML diagrams. Right. So this is an example of a class diagram in the UML. Okay, and so what this says, so basically a class diagram, what happens is we have boxes, we have these big rectangles here to represent a class. We have the name of the class, so you'll notice the EDU Georgia Tech MediaComp Simple Turtle class, and then you'll notice there's this little area in here with not much in it, right? That's the area for the properties, or really the data about the class, and I actually just took those out because it really wasn't interesting for what it was that we were going to talk about. However, what we are interested in is this other section here, namely the methods of the class, all the different things that we can do with objects from that class. Okay, so those particular all simple turtles can do all of these different things, right? So there are a number of constructors, different ways of creating this. Notice we can say turn to face another turtle. We can do things like tell it to pick up its pen, put down its pen, etc. Right? There is a move forward. There's a move forward a certain number of pixels. Move backward a certain number of pixels. Turning left, turning right, turning some arbitrary number of degrees, etc. Okay, so that's the basics of the simple turtle class. Now, on the other hand, down here we have a much, much simpler class called the turtle class. Ironically, the turtle class is more simple than the simple turtle class. That's just how they design this. And this little arrow here is the way that the UML shows inheritance, right? So turtle is a kind of simple turtle. That's all that's going on there. All right. Now, on the right-hand side, what you'll basically see is some other stuff, right? So we see this thing called a world. We see another sort of line that looks very similar to what we saw here. You'll notice it's a dashed line. Why? Because this thing up top is an interface, right? So here we're saying that this particular class, the world class, implements that interface, okay? Now, part of the whole reason behind all this is that, again, if we go back to Simple Turtle and look at the ways that we can create one, we need to specify a model display, right? And so a world is something that, and this is read as acts as, a world acts as a model display, and so we can use a world for that. Okay, what does all that mean in code? How does that play out, etc.? Let's take a look. Okay, so I'm just going to create a real simple little program here. So I'm going to go to source and I'll right click and I'll say new and create a Java class. Okay. So I'll just call it Hello Turtles. And, and so we'll see that, yes, IntelliJ goes ahead and creates the Hello Turtles class for us. Okay. So we'll need a couple of things. Like most things in most programs in Java, and a Java application, we're going to need to have a public static void main function. And the good news is that that with IntelliJ, it makes actually all of that stuff that you usually have to type out really easy. Here's how easy: PSVM, public static void main. Then I'm going to hit tab. Voila! Right? Really, really awesome. Okay. So, as I said, I want to be able to create a turtle. Let's call him Sheldon. Okay. Now, a couple of things, and again, this is a nice reminder, right? So notice it says, I don't know what you're talking about with this thing called turtle, right? Now, why? Well, there's a couple of reasons. Remember, Java by default is going to look in the java.lang path to find classes and such, right? And Turtle doesn't live there. It actually lives, as we can see, in the edu Georgia Tech Media Comp package. Okay, so again, like we've seen before with IntelliJ, I can do an Alt-Enter to import this class, and you'll see that that we have our import listed up here, right? Of course, without putting import, anytime we referred to Turtle, we'd have to say edu Georgia Tech Media Comp.turtle, and that gets very, very wordy. Okay. So Sheldon is a variable that's been declared to be of type turtle. Let's run this and see what we get. Okay, so I'm going to go ahead here and I just right click and I'll say go ahead and run that, right? And it's going to try to run my program. Well, it's going to compile it first. It'll then run it. And yeah, that's it, right? So what's going on? Well, the thing is, I ain't got no turtles. Okay. Now, if you come from a language like, for instance, C++, this is kind of different because in C++, Sheldon would in fact be a turtle object. Okay. However, remember, we're dealing with Java, and in Java, the way that we create an object is to use the new operator. So I have to say something like new turtle. Right? Then we see, oh, okay, actually there's all these different ways of creating turtles, either by specifying a model display, specifying a picture, or specifying locations and a picture or a model display. Okay, so I can't create one just yet. But as we talked about And as we saw in our diagram, a world acts as a model display. Okay, so let's create a world. Right. So there's our world variable, and I'm going to go ahead and do my import on world, just like so. And once again, let me go ahead and run this, and we should see basically that. Nothing. Okay, again, because I don't have a world yet, right? I can create a world by calling the world constructor. All right, so I use the keyword new, and then I call the constructor. And it turns out to create a world, this class, right, it does have a constructor that doesn't take any parameters, so we don't have to pass anything in. Okay, now let's see what the difference is. Right, there's our world, right? So when I run this, we see that, oh, our world basically is this little window that pops up. It says that it's a world and so forth, okay? Now, a couple of things about this. First of all, one of the things I want you to notice, notice here how it has a little red button which allows me to stop my program. What I want you to notice is when I close this window, my program's actually still running. Okay, it's not exactly a bug. It turns out that's sort of the default behavior for Java Windows. And with this particular library, I can't kind of turn that off. The best that I can do is just to remind you that, look, when you're done and you close down the world, what you're going to want to do is basically click stop like so. Okay, then our program actually has exited. Okay, so we have two classes. We have one object. All right. But again, I haven't really talked about or defined really what a class or an object is. I mean, apart from the fact that we can certainly look here and see, oh, clearly Hello Turtles is a class, right? Public class Hello Turtles, right? And we said, yes, turtle is a class, world is a class, etc. Okay. The basic idea is that a class is kind of like the blueprint. It's the formal specification for objects. It represents basically what is common for a group of objects. The objects themselves, or instances, are individuals. They are the individual items from that particular class, right? One of my favorite examples, and I actually don't remember where I had seen this, about the difference between a class and an object has to do. Think about using a rubber stamp, right? As a kid, you might have played around with these, where you get a little ink pad type thing. You sort of dab the rubber stamp in, and you can create multiple copies of the same image on a piece of paper, just stamping away, right? So in that case, the actual rubber stamp itself is like a class, right? On the other hand, each image that you stamp onto the paper is an object of that class. Okay? So hopefully that kind of gets you thinking in the right way. And again, we're going to do some more stuff with the code to kind of see that. More formally as well, what you'll see is a lot of times computer scientists will talk about the fact that classes are static or compile time entities. Objects are runtime entities, right? So the idea is, I can look at the actual source code to view what the class is, but the object actually doesn't come into life or doesn't really do anything until the program itself is actually running. Okay, and that's all they mean by that. Anyways, now that we can create a world, let's create a turtle and put the turtle in the world. Oops, yes, the world. There we go, just like so. Okay, so now when I click run, we see there's our turtle in our world, right? There's Sheldon himself. Okay, so we have a world object that we can see. It is this whole window here, and we have a turtle object referred to by the variable Sheldon. Right, so there is Sheldon. Now, as I said, this whole abstraction about turtles and turtle graphics and so forth. Basically, it goes back several decades actually to Seymour Papert, who had these ideas about teaching children to be able to program, and so we have this turtle that kind of represents that almost represents a sort of robot, and the turtle is the theory is that the turtle's kind of dragging a pen behind him in his tail along the paper. So, for instance, I could tell Sheldon to move forward, like so, right? And in doing that, when I run this program, we see that, yes, Sheldon moved forward sort of the default number of turtle steps, or really pixels, and drew a line behind him. Okay, so that gives us, right, shows us that that our objects have abilities to do certain things, right? Like, for instance, all turtle objects can be told to move forward. Okay, we can tell him to move forward a different amount, like so, right? Incidentally, if you're watching this, right, so IntelliJ is kind of putting in that pixels colon part, but that's not something that you actually type. And I think actually you can turn off that feature if that kind of bothers you, that it's showing you that. So notice, he actually did move forward, but a much, much smaller amount, right? And you can kind of play around with these things. So we could say, okay, maybe what does 30 look like? Right, and so on. All right, so we can get Sheldon to move forward a certain number of pixels and so forth, or we can just use the sort of default number of pixels. Other things that we can have Sheldon do. So, for instance, I can tell Sheldon to turn right or left, right? So I don't care, I'll pick one. Let's say right, and then I'll have Sheldon also move forward from there. Let's see what that gives us, right? So notice he moved up to here, he made a right-hand turn, he actually turned 90 degrees to the right, and then moved forward the exact same number of pixels. Okay? If, however, you didn't want to turn exactly 90 degrees, what you could do is you could do something like this. Okay, we could call the turn method, and again, I could come over here to take a look, right? So notice there is the turn method that takes a number of degrees. So for instance, I could say maybe turn 30 degrees. Right? And again, make sure that that's shut down. Okay. And yeah, now we see him kind of move off in that direction, right? If I wanted him to move off in towards the left rather than the right, I could just change this to negative 30 degrees. Okay. So you get the basic idea behind this. Now, so we basically have, we have two classes, two objects. Well, three classes, two objects. That is, we have the world class and a world object. We have the turtle class, and then the turtle object, and we do have our Hello Turtles class. Although we don't actually have an object of that class. But let's get another turtle on here. Right, so Sheldon's looking pretty lonely, so let's put another turtle into the world with Sheldon, like so. And now notice, right? So there's Sheldon, and right here is the other turtle, Shelly. Okay. So bad puns aside, notice we do have two turtles in our world, right? So from a single class, the turtle class, I am able to create as many objects of that class. I was going to say as my little heart desires, but not quite. Really, as many objects as my computer's RAM can handle. So we can create these objects, and you'll notice that turtles are similar to one another. And so what I mean by that is that, when we talk about object-oriented programming, and we talk about this concept of objects, we talk about the fact that, well, objects have properties, data. So for instance, here in the world case, I left some of these showing. So it has a background color that is white. It has a default width that is 640. It has a default height that is 480. It keeps a list of all the turtles that are in it, right? So that's the data. But the object, and what really makes it useful, is the fact that it has methods. That is, it is capable of doing things. Okay? So here's the thing to consider. Given what we see here with a turtle, what might some of the properties of the turtle be? Right? So if you take a look, if you just think about this for a couple of minutes, I mean, some of them are pretty obvious, right? Very clearly, if we were building the turtle class, we do need to be concerned about the location of the turtle, right? And we might talk about, for instance, its X location if you're thinking about, and a Y location if you're thinking about something like a Cartesian plane and so forth. But we could just sort of summarize that as a location in general, right? Also, we're probably interested in the fact of the direction that the turtle is facing, right? So right now, Shelley is facing straight up, and Sheldon is facing roughly 30 degrees off to the left. Okay, so we have a location, we have an orientation or the direction that it's facing. Notice very clearly we have some colors going on here, right? So Sheldon has a particular shell color and head and leg colors that are different than from Shelley's. Okay, so again, some things there. The point being, right, notice all of our turtles have a location. They don't have the same location, right? Sheldon's there, Shelley is here. All of them have an orientation or direction that they're pointing. Again, that can be different, right? So the class really represents that notion of here, all of these objects are going to have this collection of properties and this collection of behaviors, right? However, the particular values of data are oftentimes going to be different, right? Another example of this, think about students in a classroom. Every student has a name, right? Generally, not everybody has the same name, and if one person in the class changes their name, that doesn't necessarily mean that anybody else's name is going to be changed, okay? So that's all we're talking about here. All right, so we have these two turtles like so, right? Let's kind of look at just playing around with this a little bit more. Okay, maybe what I'll do is I'll have Shelley turn 180 degrees. Okay. And so we see, yeah, now Shelley's pointed off in that direction. And then maybe we can say, okay, Shelley is going to move forward something like 50 pixels. And then Shelley can turn, and I'll say -15. And I'm just kind of pulling random numbers, semi-random numbers out of my head here for some of this. I don't know, maybe then move forward 150. All right, so let's take a look at that. There we go. Yeah, so they're kind of separated and so forth. I don't know, maybe I want to do, let's do 45 for that. Oops, sorry. All right, let me go ahead and run that. Yeah, there we go. Okay, so now they're kind of separated and so forth. So let's look at a couple of other things that we can do with these. One thing that you can do with our turtle is, notice there is the turn to face. So we can have one turtle turn to face another turtle. Right, so for instance, after all of this, maybe Sheldon actually notices that Shelley's out there, and so we'll have Sheldon turn to face Shelley. See what that looks like. Right, there it is. Sheldon is now facing Shelley. Okay, and maybe we want Sheldon to actually move to the same location. Okay, now we could certainly employ some basic geometry to be able to compute that, but and let's actually see what kinds of stuff that we can do perhaps without having to do the work ourselves. Okay, so let's see if I remember right. I think that there is actually a way of finding out just how far. Yeah, there it is. Get distance, right? So get distance. Notice it actually takes an x and a y. Okay, so that means I got to do a little bit of work here, right? I don't have get distance to necessarily another turtle. What I can do though is if I can find out the actual distance to, for instance, to from Sheldon to Shelley, I can then move Sheldon the appropriate number of steps. Right? And then that basically means if I want to use get distance, I have to be able to get the x and y position of a turtle. Right? And again, if you kind of scroll down, if you scan through here, what we should see is there we have the get x position and get y position. Okay, so let's kind of throw those together. Okay, so I'll do something like say, all right, Shelley x is equal to Shelley dot get x position int Shelley y is equal to Shelley get y position, right? And now we have the coordinates of Shelley on the screen. Okay, and then I can say something like, all right, the distance is going to, actually, let's let me go back. I think it's going to be a double. Get distance, yeah, notice colon double, so that's telling it's going to return a double. All right, so double, and then I can say I'll do something like Sheldon, Sheldon, get distance, and then we'll say to Shelley's x and to Shelley's y. Shelley's y, like so. Okay, so now we know exactly the distance between the two turtles. And then we can have Sheldon move forward that amount of distance, namely dist. Okay, now, what is the issue here? Well, notice, basically forward takes a whole number of pixels, not a double. So we do need to do some sort of typecast here. And so I'll simply put in a typecast saying, yeah, convert that or see that as an integer. Okay, so let's see what we have. And yeah, there it is, turtle love. Okay, so now they're at the same location. Okay. So it should give you a good idea. Hopefully that gives you a better idea of the distinction between classes and objects. And then as we move forward, we're going to start talking about, for a particular class, we'll talk about its properties. We'll talk about things like classifying different kinds of properties, the relationships between classes, and so forth. If you have any question, you're in my class, hit me up on Piazza. Again, if you found us on the internet, just shoot me something down in the comments.